Welcome students. Hope you are doing fine, spending quality time with your family, and I hope studying as well. Today we are going to do chapter 14 statistic. The topic of this chapter we are going to cover in this session is mean of group data. In your previous classes you have studied that statistic is science of collection, presentation, analysis and interpretation of data. We know that collection of data can be primary as well as secondary. Primary when I collect the data myself and secondary when I take the data from somewhere else. Presentation of data can be in two forms, tabular form or graphical form. Let us review how we represent the data in tabular form. The list of your class can be written in alphabetical order, names of all the students. This can be alphabetical arrangement. When the data is numerical, it can be arranged in ascending or descending order. As you can see, by XI we are representing marks of 11 students. When these marks are arranged in ascending order, we can draw some results. Like I can see that 17 marks are scored by 3 students. Data can also be arranged in discrete frequency distribution table. When there are number of observations and there is repetition in observations, then we form this type of table. You remember putting tally marks. Yes, keep looking at the observation and put the tally marks. This gives you the frequency of each observation. To condense this information, this table further, we can also form grouped frequency distribution table. You can see that the whole range of data here is divided in class intervals 1 to 10, 11 to 20, 21 to 30 and so on. In each class interval, we have noted the frequency, that is the number of students belonging to that class interval. Class interval can also be from 0 to 10, 10 to 20 and so on. This type of class interval is inclusive because the upper class limit is included in this form. But here this type of class intervals are exclusive because here 10 upper class limit is not included. Rather this 10 is included in second class interval. We can form less than greater than cumulative frequency distribution table using these tables. We will be looking at it in our next session. When it comes to analysis and interpretation of data, we need some representative value because just at looking at the data, we cannot draw any result or take a decision. So, that representative value of data which we find are called measures of central tendency. One of the measure of central tendency is mean. So, let us understand the meaning of mean. With an example, I have a friend Rashmi. She teaches two group of students, group A having 5 students and group B having 7 students. She wanted to know which of these two groups is performing better. She gave them a test and noted their marks. So, here are the marks of group A and group B represented by XI. N represents total number of students in the group. To explain to the students the meaning of mean, she put a box in front of group A and asked all the students to collect their marks in the box. As marks cannot be collected, she gave all the students number of marbles equal to their marks. So, all the students collected their marbles in this box. Total number of marbles turned out to be 15. Then Rashmi decided to distribute these total marbles among all the students equally. So, these 15 marbles were distributed among these 5 students equally. Each received 3 marbles. So, total number of marbles divided by number of students gave us the number of marbles received by each student. These 3 marbles are nothing but actually the mean of group A. Same way, Rashmi calculated mean of group B. So, the total collection turned out to be 14. And these 14 marbles were divided among 7 students equally and each received 2 marbles. So, the mean turns out to be 2. Rashmi came to know that group A is performing better than group B and she decided some remedial measures for group B. So, you saw that it helped, calculation of mean helped Rashmi in deciding how to teach, how to improve her teaching. Arithmetic mean in this case you saw turned out to be sum of all the observations divided by number of observations. So, this is actually our definition. Now, let us learn how to find out mean for discrete frequency distribution. We are taking an example and in this example you can see weight of 12 students are given. The table says these 4 students, each of these 4 students have weight 67 kg. Each of these 3 students have weight 70 kg and we are asked to find out mean weight. I hope students now you understand what is the meaning of mean weight, right? Just take the case of marbles. Suppose all these 4 students are given number of marbles equal to their weight, then what will be the total number of marbles collected by these 4 students? It will be 67 into 4, that is 268. So, this is the weight of these 4 students. Similarly, we can calculate weight of these 3 students. Each of them has weight 70 kg. So, these 3 will have weight 210 kg. So, to find out total weight of these 4, we multiplied Fi and Xi. So, this is what we are going to do for all the observations. So, you can see Fi into Xi in all the cases. Then the total number of marbles, we have to add them all. What is the sum we got? 843. This is represented by sigma Fi Xi. So, this is our total sum. To find out the mean, we will divide this sum by number of students. So, the formula turns out to be mean is equal to sigma Fi Xi upon sigma Fi. Sigma Fi Xi has value 843 and sigma Fi is 12. So, we get after calculation the mean weight as 70.25 kg. This was the direct method of calculating the mean. There is one more method we can use in this form of tabular representation. Let us learn that. Now, let us calculate using assumed mean method the mean of the same question, same data. Here, what we are going to do? We are going to simplify the values of xi's further. How? By subtracting a common number from all the xi's. What that common number is going to be? It is going to be the middle value of all the xi's. As you can see, there are 5 xi's, the middle one is 72. So, I will take this number as assumed mean and subtract it from all the xi's. This will simplify the calculation. So, the first value is 67 minus 72. It will give me the answer as minus 5. What does this minus 5 represent? It is DI, that is deviation of assumed mean A from xi, in this case x1. So, I am going to calculate DI for all the observations. As in this case 70 minus 72, it is going to be minus 2. As in previous case, I multiplied Fi and Xi. In this case, Fi and Di will be multiplied. So, 4 will be multiplied with minus 5 gives me answer as minus 20. The same way, Fi3, F23 multiplied by minus 2 gives me answer as minus 6. All the products are there. Now, I have to take the sum of Fi and Di's. How should I find this sum? Because some of the values are negative and others are positive. I will add negative values separately and positive values separately. So, minus 20 minus 6 gives me answer minus 26. 2 plus 3 gives me answer 5. Solving these two, minus 26 plus 5 gives me answer minus 21. So, this is sigma Fi Di. Now, mean of Di's, that is D bar, is going to be sigma Fi Di upon sigma Fi. So, minus 21 upon 12. But this is D bar. And what was my target? My target was to calculate X bar. How to go for X bar? That is mean of Xi's. As I have subtracted A from all the Xi's, now I am going to add that A back in D bar. So, the formula for mean X bar turns out to be A plus D bar. D bar means sigma Fi Di upon sigma Fi. Substituting the value, I get the value of mean as, this is X bar, mean as 70.25 kg. So, again the same value. You can see by using two different methods, the value of mean remains same, that is 70.25 kg. So, these were two methods of calculating mean. When we compare these two methods, we can see that in FIXI, that is direct method, the calculations were a bit tedious, but using assumed mean method, the calculations became quite simple. Now students, let us learn to find out mean of grouped frequency distribution, that is when the data is represented in grouped frequency distribution form. In this type of distribution, we will learn to calculate mean using three methods. So, let us see what our question is. Here you are given distribution of daily wages of 50 workers of a factory. We have to find out mean daily wages of worker. Here daily wages are in rupees given to you as 100 to 120. In this range of daily wages there are 12 workers. In 120 to 140, in this range there are 14 workers. That is salary of 14 workers lies in the range of 120 and 140. So, this is our question. Total number of workers are 50. Let us see how to find out mean by direct method. So, first we will find out mean of this data using direct method. Do you remember, in direct method we have Xi and Fi and used to calculate the product FI/Xi. But in this case there is no Xi. Then how to do it? Here in this case, for each class interval we are going to find out Xi. This Xi will be the middle value of each class interval. It can be calculated by using this formula, upper limit plus lower limit upon 2. This Xi is called the class mark. So, for first class interval, the value will be upper limit, that is 120, plus lower limit, that is 100, which turns out to be 220 divided by 2. So, the value comes out to be 110. For second class interval, similarly we can calculate and we get the value x2 as 130. What is the next step? To find out the product Fi into Xi. So, the product is going to be 12 into 110 as 1320, 14 into 130 as 1820, and so on. We can calculate for other class intervals also. Now, we will take the sum of all these products, that is sigma Fi xi. It comes out to be 7260. Now, our formula for mean is sigma Fi xi upon sigma Fi. So, total 7260 will be divided by total number of workers, that is 50, and we get mean salary of each worker as 145 rupees and 20 paisa. This was the direct method. Now, let us learn the second method for this type of distribution. What was the name of our second method? Assumed mean method. So, in this method, as we did previously, we are going to calculate DI. But for DI, we need assumed mean. What is assumed mean? Assumed mean is the middle xi. So, the same way we have calculated xi and the middle value is 150. In this case, this is our assumed mean A. So, we will calculate DI. For first case, it will be 110 minus 150. So, it gives minus 40. For second, it will be 130 minus 150 and it will give value minus 20. So, we get DI. Next step, Fi into DI. So, Fi 12 will be multiplied with minus 40 and the answer is minus 480. Second Fi, this is F2 14 will be multiplied with second Di, that is D2 minus 20, and the product turns out to be minus 280. Similarly, we can multiply for all class intervals. Next step, again the same, add all, but here some of the values are negative and some are positive. So, we will add negative values separately. Minus 480 minus 280. What is the sum? It will be minus 760. For positive values, 120 plus 400 gives the answer 520. When we solve these two values, minus 760 and plus 520, we get the answer minus 240. What is this minus 240? This is sigma Fi Di. Let us put these values in the formula of mean. Our formula was A plus sigma Fi Di upon sigma Fi. If I substitute the value in place of A 150, sigma Fi Di minus 240, sigma Fi 50, I get the mean as rupees 145.20, that is again rupees 145 and 20 paisa, which was the same as we got through direct method. Let us look at the third method where we are going to simplify DI further. Our third method is step deviation method. In this method, we take the class width of each class interval and divide each xi with the class interval, class width. So, for this class interval, the class width or class size is upper class limit minus lower class limit, which will be 120 minus 100. It is 20. So, class width is represented by h, and in this case it is 20. We are going to divide di, that is xi minus 8. Do you remember we calculated in previous method? Xi minus a, which was di, will be divided by h, which is 20 in this case. So, for first class interval, we get the value as 110 minus 150 divided by 20 as minus 2. We call these values, we represent these values by the variable ui. Got it? And we calculate this ui for all the class intervals. As in all the cases, we calculated fi into xi, fi into di, fi into now ui. Yes. So, we are going to multiply ui and fi. So, 12 into minus 2 gives minus 24, minus 1 into 14 gives minus 14 and so on. The next step again is to add all the fi into ui's. Sum of these values. Again you can see there are few values negative, few are positive. So, minus 24 minus 14 gives me minus 38 as answer. 6 plus 20 gives the answer as 26. When I solve these two, I get the answer as minus 12. This is sigma fi ui. To calculate the mean, now this expression represents u bar, that is mean of all the ui's. But you remember that I have divided by h 20, all the xi's were divided by 20. So, I have to now multiply by h. Again I subtracted assumed mean a from all the xi's. So, now I have to add it back. So, I will add a. So, the formula turns out to be a plus sigma fi ui upon sigma fi into h. Substituting the values, we again get the mean as 145.20. So, in all the three methods, we got the same value of mean. So, students, now let us compare these three methods. You can see that we are now having in front of us calculations of direct, shortcut as well as step deviation method. We can see that in these three methods, the calculations are simplified in step deviation method. So, you can judge looking at the question which of the method is most appropriate for that question. So, students, now you try these questions for practice. Do this assignment. Question number 1 is, you need to explain what do you understand from mean. Remember the example of marbles? In question number 2, the marks obtained by 30 students of a class are given in table. You need to calculate mean marks obtained by the students. In question number 3, the distribution below shows the number of wickets taken by bowlers in one-day cricket matches. You need to find out mean number of wickets from this table. So, do try these questions. So, students, in today's session, we learnt about how to calculate mean using three different methods. The first method was direct method, in which we use two formulas, mean is equal to sigma xi upon n or mean is equal to sigma fi xi upon sigma fi, depending on the type of distribution given to us. In second method, that is the shortcut method or assumed mean method, we use the formula mean is equal to a plus sigma fi di upon sigma fi. In the third method, step deviation method, we use the formula mean is equal to a plus sigma fi ui upon sigma fi into h. I hope you have understood the session well. Thank you so much.